Okay, here's a quick introduction to Bash Tutorial 5 that you will do on your own. Um, and in it, you're going to play with two things, but mostly for loops in Bash. But first, I'm going to show you how you can do redirection slightly differently. So that's the first part here. I'm going to illustrate that very quickly for you. So the idea is that sometimes you want to redirect something and append it to a file rather than erase the file if it exists already. So for example, let's assume that I would like to have a file containing prog1.asm, prog2.asm, prog3.asm, and prog4.asm. And we've played with that in the previous lab. They're just simple program that we've put in directories somewhere. But let's assume that for some reason I wanted to have all of them together in one file. So what I could do is this. I could cp prog1 asm. I could start by copying prog1 asm into all progs asm. So now all progs asm contains a copy of prog1. And what I can do now, I can cat prog2.asm. So by itself, this will display the file on the screen, but I can say add it to the end of all progs. And see that double chevron here will say take the output of the cat operation, which will display everything, send it to all progs, but put it at the end of all progs. And so I can do the same thing now with 3, and the same thing with 4, and that's it. So if I look at all progs, I will see that it has, so see, this is the beginning of the second program here, and there was nothing interesting here, but it was just for us to play with different files. That's the beginning of prog 3 and the beginning of prog 4. All right, so if I remove all progs and I try one of the previous commands, cat, if I do that, it will still work. The file all progs doesn't exist because I've just erased it. So what it will do, it will simply put it inside. So I use cp at the beginning here, but I could have actually done the same thing for prog1. I could have just cat prog1 redirect twice, and so that would have appended. So that's the first part. Here you'll play with cowsay, which is an interesting little command just for fun. So we can skip that for right now. What is neat with Bash, actually, and now that's going to be the beginning of writing scripts, is that you can create loops. So let me illustrate that very briefly for you. For I in 1, 2, 3, 4, 5, semicolon, do. We're just going to echo I, done. All right, several things here that are new. So definitely the for loop is new. And here I is going to be a variable. So variables are names that start with a letter, and it can be followed by letters or numbers, pretty much the same as in programming language. And then semicolon is new. So for I in, so I is going to take all the values 1, 2, 3, 4, 5. So the semicolon is a way of separating commands. So do normally would go on the next line. I like to put do on the same line. So semicolon is a way of separating my for command from the do command. And echo, we've seen that before, it just displays information on the screen. And then when I use the variable, I'm going to put a $sign in front of it. So when I declare a variable, I just use its name. When I use it, I put a $sign. And the done is the end of the for loop. Okay? And it will display 1, 2, 3, 4, 5. So that will have displayed that. You'll see at the end of this lab, hopefully, the power of such a command. If I wanted 1, 2, 3, 4, 5 on the same line, then I would use a different echo. So I'm going to bring back my command. And you're going to see here that actually Bash is clever enough that it's putting everything on one line. So I could press enter now and get the same command repeated. If I want to modify, I'm going to go back through that line, and I can say echo -n means do not go back to the next line. and stay on the current line, display the variable I. If I do that, then I get 1, 2, 3, 4, 5 here. If I wanted a space in between, I would go back here and I would say I want to display I, a space. So I'm going to block the string that I want to display between double quotes. And if I do that, then I have my 1, 2, 3, 4, 5 that is printed nicely. If I wanted to go back to the next line after that, so this is all programming. You know how to do that in Java or Python. So here, if I did echo by itself, then now I can print my 1, 2, 3, 4, 5 on the same line, and then when my loop is done, the next command will just echo nothing, so it will just go to the next line, and that's what I get. So for loops are great. They're going to allow us to do many different things. So I'm giving you several examples. Let's take a look at this. This is more sophisticated. So sec for sequence generates a sequence for you. So 110 is going to generate 10 numbers. Sec 10, 15, what you would expect. So instead of enumerating the different values that I want I to take, if there's a lot of them, I don't have to print them. Sec is going to be great. It's going to generate that. So if I want to use a for loop that uses sec, because sec is a command, then I have a different syntax. I'm going to say for I in back quote. So that's a back quote, not a regular quote. Sec 110 back quote semicolon do equal I done. Okay, and I get my 10 values. So this is really nice here because whatever you put between back quotes can be a Linux command, and whatever that command outputs, then that becomes every value of I. So I will take all the different values that whatever is here generates. So if we repeat that, we get the numbers. But if I had said ls list all the ASM files in my directories, echo I, then it would have listed all my assembly language programs. Or if I would have said everything that starts with P, anything following P and then .asm, then it would have given me just the assembly file. But what is important here that I want you to get is that whatever you put between backquote can be another command. And so whatever that command generates, then that's what your I variable is going to take its value from. Here, if you want to generate letters, we have a slightly different syntax. For J, I can use any letter that I want. So A through F, do echo $K, done. Okay, so I have A, B, C, D, E, F. Challenge 1, use the man page, figure out how to make the loop print from 20 down to 1. So I've shown you how to generate numbers in increasing order. Look at the manual page for a sec and get that going. You can also, of course, generate nested for loops. So here is one for I in sec 1, 5 for 4, do for j in A, B, C, D, do echo I and j, done. So that's the end of the for j loop, done. That's the end of the for I loop. Oops, misspelled, I'm going to have a problem. Command not found. I need to erase this. All right. So for I in 1 to 4 for j in A, B, C, D, and I see 1, 2, 3, 4. A, B, C, D, A, B, C, D, and the behavior is what you would expect of any other language that you know. The inside loop, the for j loop, goes faster, so that's why I enumerate for the letters, through the letters first, and then through the numbers second. All right. This little trick you can solve by, so I'm giving you an idea of, if you use a double for loop, if for I in 1, 2, 3, 4, do for j in sec, oops, 1I. So if I use the I variable of the previous loop, then echo ij, done, done. So what you see here is not obvious, but let me add a little minus n right here, and then echo right here. All right, 1 1 1 1 2 2 1 3 1 3 2 3 3 and so on. So you see the idea of this triangle occurring right here. So if you have the second loop that depends on the variable of the first loop, you can get this triangle pattern going on here. At the beginning of the semester, we have our Linux operator always generate new accounts for the class. And there's a command called add user. So if you're a super user of a Linux system and you want to create an account, the command is add user. And so that person will very likely use a bash for loop and will have a loop that add user many times and will generate accounts that are CSC231A, but then AA, AB, AC. And then when the loop goes to AZ, it repeats, so see nested loop BA, BB, BC, down to BZ. So I'm asking you for this challenge to write a loop that generates this whole series of strings. So CSC231A dash has to be part of it. And so if you can do that, it would be no problem to add the command add user in front of it, and then to actually run that, and you would have a loop that in no time would generate a multiple of 26 accounts, here in this case 52. Okay, looping through files, we've just shown that before. Here, something to give you an idea of why for loops might be useful. If I wanted to have a listing of my assembly file, but I just want the top 5 lines. This is what I could do here. Let's see if I can copy paste that. Clear. Yeah. It worked. Let's see what I did here. Actually, you know what? We're going to do it from scratch. For I in, actually it's nice to call the variable with a name that makes sense. For file in star.asm, so all the assembly file in my directory, do echo, I want a nice display, so I'm going to display a nice little bar. Then I'm going to display the name of the file, and then echo a nice little bar. And then I'm going to head -n5 file. I just want the top 5 lines of the file. After I've done that, a blank line, and that should be enough, so done. Alright, so what I generated here is the header of all the assembly files that I have in my directory. Okay, and that's pretty simple to do. Okay, if I wanted all this to be, so this is hard to see because it's all on one line, but if I wanted to capture all this in a file called all header 5 asm, that's it. Now if I look at this file, all header 5, then you see that I would have, and by the way, that is interesting, it's listing itself here, and because it's being created by the command but exists in my directory, then there's an empty header for it. But all my files are here with 5 lines, the top 5 of each one, and I have a very nice display. So again, the power of bash is that I can, from the keyboard, generate a lot of work very, very quickly, much faster than I would if I were playing with a mouse and a graphical user environment. Challenge 4. Oh yeah, I'm going to show that to you. You can get a copy of the nqueens.java code if you don't have it yet in your directory. And if you run it, Java and Queens 8, don't forget to add the -q that will make it quiet and not display what's going on. If you do that, it's going to run the program and then stop as soon as it finds a solution. And here we see it took 0.18 millisecond to just do that. If I were to, if I wanted to plot this and I wanted some data as to how long it takes for n varying from 8 to 20, for example, then I could say for n in sec 820 do Java and Queens n quiet done. And now you see that very quickly I've run my program 20 times and I have the execution time for each one. So what I'm asking you to do is to do something slightly more complicated where you actually display n as well as the execution time. And that is your last challenge. Hi, one additional piece of information is that for your for problem 4 of homework 7, you have to submit a for loop written in bash, actually nested for loop. So you can just copy paste in Moodle if you want, and that would work. Otherwise, if you want to be a little more sophisticated, you can create a bash script, which we'll do very soon, but we haven't seen yet. And so I'm going to give you an example of how to create a bash script very, very briefly. Assume that I want a command in bash that displays some kind of square filled with stars. So I could do something like this. For I in sequence 1, 5, do echo some stars, done. All right, so that displays my square of stars, and that's great. Let's assume that I want to make this a script, put it into a file so it can be executed on its own. So this is how I'm going to do this. I'm going to bring back the command with the arrow key. I'm going to copy it in my buffer. All this, copy. Now I will create a script file. So I'm going to call it homework 7_4.sh. sh typically is an extension for indicating that we have a bash script shell file. And now is a little trick that you need to do in order to make a script or a series of bash commands executable, is that you need this as the first line. It indicates what interpreter to use in Linux in order to understand what the remaining lines are. And bash is the interpreter, it's also the shell. And so I'm going to paste my command that I had copied, and I'm going to align it nicely. I don't need the semicolon if I put down on the next line. All right, so I have now my my for loop that I've debugged, and I know it works, I know it displays the square. It's formatted nicely. I can quit this, XSC, and in order to make it executable, ch to make this file, chmod, change the mode, the privileges associated with the file, plus X. Everybody who has access to it should be able to execute homework 7 for sh. And so now I can say Linux, look in my directory for homework 7 for sh and run it. Just press enter and it will execute the bash commands inside the script. And that's it. So I would recommend that you you do this for your problem 4, and that's what you can submit, that particular file or copy paste. All right, good luck.